So today we are going to talk about angle between vectors or angle of a vector. So you might find it by saying angle between two vectors or angle between a vector or angle of a vector. Of I think it should be vectors since you at least need two vectors to measure an angle, but not quite sure. Okay, so don't blame my English right now. So suppose I took a vector which is this. Not gonna name it, or I might, not sure. Suppose I took this vector and I took another vector. So let's take another vector, right like this. Let's thicken it a bit. So like this, and let's move it a little bit downwards so we can write some things as well. Let's take a second one. I think we will do four of them. So four of them. They're not exactly the same. I will change them a little bit. So let's keep this like, let's keep this overlapping like that. Um, okay, this one. Mm, this one. This one. And a final case, which will be this one. So these are any two vectors. Not gonna name them, okay? But you can name them, no problems. So let's call this case 1. This is 2. This is 3, and this is 4. So these are just some cases that I want to see what will be the angle of the vector. So what will be the angle between the vector. So before we do this, let's actually see what the angle of the vector can actually be. That actually rhymed. Pretty cool, right? Okay, so suppose I say the angle is theta. It means that the angle, um, the maximum, the minimum angle will be 0 degrees. So I'm measuring in degrees. You can also convert this to radian, no problems in that. And it can go up to 180 degrees. So that's the key point right over here. Okay, so it must be from 0 to 180 degrees. Also, this can be done when vectors vectors are joined either by head and head, head and head, or tail and tail. So also let's represent this one. So let's take number 3. So number 3 is pretty cool one. I like the shape of this. So if you have the measure angle, you will actually measure it by um, tail. So this will be considered a tail. So this part is, let's change the color actually. So this is the head, while this is the tail. So we are doing tail. So it's tail right over here. So tail. Okay, or you can do head. So let's take this, copy it, move it. Since I'm trying to represent the same vector, I can parallelly transform it, so that we learned in the previous video. I can move the vector without worrying about it. So let's move it down. I'm not changing the direction, and let's move it like this, with I'm not changing the direction still. So if I'm not changing the direction, I can move it. So now we are actually doing head head. So this is what it means by head or tail. So now the question that I have for you is, what is the angle between the vectors approximately? So I'm just gonna take some rough measurements, not the actual thing, just gonna guess it. Suppose this is 60 degrees, and since the whole circle is 360, this above part will be, so let's make it right here. This will be 360 degrees, right? So sorry, this will be 300 degrees, and this part will, let's make it white. will no white. What's something that will stand out? Very. This will be, let's make it nice, 60 degrees. Right over here, this also will be 60 degrees. And the back one, this will be 300 degrees. So the question is, which one is correct? So if you look right over here, it must be between 0 and 180 degrees, which means the bottom one is correct. So if you correct it by tail method, you get 60 degrees. And even if you do it by head method, oh sorry, yep, I did a mistake. Sorry. That's a big mistake. Sorry, very much sorry for that. Really forgot how angles worked. So this is actually 300 degrees. Pretty stupid of me, but never mind that. And this is 60 degrees. So in this case also, you will take the smaller value, which means this is the correct one, which means by whatever method or whatever means that you do it, you will always get the correct answer. So you must just use the head or tail method. So let's go back and guess the angles. So let's look at which one you would choose. So would you choose this one or this one? So let's do it from 3 since we already did it. Obviously, you will choose the smaller one. So you're always supposed to choose the smaller one. Let's say this is 60 degrees. So here, will you choose this one or this one? Since this is a larger angle than this one, you will obviously choose that one. And this kind of looks like 120 degrees. Just guessing. Sorry, wait a minute. Also, I want to tell you a fact. I would say, I don't know how would you call it. So you know that this will be 90 degrees, right? So 60 must be right over here, right? Which means this must be actually greater than 90. So this, me calling this 60 as actually a very bad guess if you think about it, right? So this is let's call this 120. We call this 60. Never mind that. Since we are just taking some random values, but it's by guessing, it must be about 120. Pretty stupid of me, but never mind that. Also, over here, the angle will be, think about it. What's the angle? Look at the directions. If I connect them by head method, boom. What's the angle? There is no angle. It's 0 degrees. So the angle is 0 degree. But right over here, if I connect them head by head, so if I connect them, think about it. If I connected them by head, they are exactly opposite. So it's 180 degrees. Think about it. So right over here, the angle is 180 degrees. So don't mind that this is 60 degrees, okay? So let's also write that. So 60 degrees is just supposing. Just supposing. And this figure is also not to scale. Let's write that as well. Figures are not to scale. Since I don't want to again like write 120 and fix this all up. So that's going to be the best that I can do. And also over here. So figures are not to scale. Yeah, that gives me peace. Okay, so that was it for today's video. I hope you understood how to measure angles between vectors. I think I explained it pretty clearly, except this one, because it's supposed to be around 120 degrees, I would say. But I wrote it 60, never mind that. In the next video, we are going to talk about addition and composition of vectors. Till then, bye-bye.